Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL course on building energy systems and auditing. We are in the module number 7 and this is the last lecture on the module number 7. Module number 7 is basically we are dealing with the building operational energy and the energy retrofit. In the last lecture of the module number 7, that is lecture number 35, we will going to see the energy retrofit of building and we will analyze that one from the point of view of the cost, energy and the carbon payback. Also we will discuss some the concept of the cool roof systems. So, first of all let us discuss the cool roof system, because as you know the most of the heat gain in a particular building is actually through the roof, because the most of the time the roof is under solar radiation and extensive solar radiation, particularly in the climatic zone, in the hot and dry climate, composite climate and also the warm and humid climate. A extension of the daytime and also that daytime extension is in the summer time in the that depends upon the latitude, but this extension of the daytime and the amount of the incident solar radiation creates a havoc problem in the top floors. So, there are some guidelines which actually first has been derived by Government of India, the Disaster Management or National Disaster Management Authority NDMA, as a handbook. The name of the handbook is Heat Wave Action, House Owners Guide to Alternate Roof Cooling Solutions. It was published in 2021 April. See, as I told that this roof is one of the potential area where there are enormous amount of heat gain is there, and it actually increase the average temperature almost around plus 45 degree in the some of the areas of our the composite and the hot dry climatic area, mostly in the Uttar Pradesh, Delhi, Rajasthan and all. And this particular create lot of the issues, and then the excessive amount of the air conditioning load, and if not air conditioning load, if you cannot actually in the hot dry climate we cannot open the windows, because the outside air is extremely the offensive in that nature from the temperature point of view. So, the one of the solution is the cooling the roof systems. So, there are a manual. So, I will actually forward this manual in our forum, and also I will go through this manual little bit. So, this particular the handbook by NDMA has given so many type of solution, and these solutions are basically can be employed in our the residential building or any type of building to safeguard the topmost floor. It can be go with a bamboo thatch screening type of solution, green net shading, mist cooling solutions, cool roof paint. I think there is a small there should be a T over here, it is not paint, it is a paint. Then the gravel roof, the modified bitumen membrane, then the thermoplastic members, the paints and finishes on the rooftop, hollow concrete tiles, heat insulation tiles, the inverted earthen pot method, mud pustaka, that kind of a thing is also there. The extruded polystyrene method, we have already discussed that one in the earlier discussion. Lime concrete is a very age old kind of solutions which is available with us. Broken china mosaic or the cellulose fibers are also applicable. So, in that particular guideline or that particular handbook, if we go, We will actually this particular handbook is based on the different locations as per our zonal map, climate zone map. India is divided into 5 climatic zones. So, it is all the solutions which was mentioned over here may not be applicable for all the type of climatic zone, but we can select that. It was mentioned that which climatic zone is has to be, and there are 2 type of expertise that may required. The first one is do it yourself kind of a thing that we can do by ourselves only with a little help of somebody others. In second case, maybe some of the cases we require some kind of a technical expert. So, that is also mentioned in that handbook. And that the building typology, there are 4 type of typology. If this is a sloping roof structure, which kind of scenario we can go, if it is a flat roof, if it is a new building, or if it is the existing building. So, based on that, the different type of typology of the building is also suggested in that book. And in these books, each and every method that what we have just now discussed is given this kind of the visual, the symbols. The climatic zone HW, that means hot and dry, WH warm and humid, and composite is CM. I think this is CM is composite, right, CM. So, these 3 climatic zone I can go with this bamboo thatch or palm leaf roof screening. So, it has mentioned in a diagrammatic view also what are the different layers and what are the different type of the supporting structure is required. Building typology also they have mentioned, it is given as a do it yourself kind of scenario. You do not need any kind of expert. See, this is that symbol. So, like that it has mentioned over here, and also in that particular each page consists of one of such of kind of the treatment. The material available, it is a readily available material because thatch and those palm leaves are available everywhere. It is a lightweight, it is a high insulation capacity, it has a comparatively less cost with compared to the other type of material treatment. Ridge is weakest point of the thatch roof. So, that is also mentioned over here. It prone to fire or fire risks, or those also I have mentioned. So, it is giving you almost medium to high kind of the sensibility or from the thermal gain. 6 to 8 months is one of the issue probably for this particular thing, that after 6 to 8 months you may need to change the scenario, because thatch will definitely going to have a problem after a monsoon season or so. So, that period 6 to 8 months or whatever may be, that is giving you the what is the time period of this particular installation, and then thereafter you have to change it. The cost is mentioned as less than 100 rupees per square feet. So, that is also you must when you choose from the basket you must know. Then there are steps, that first you have to clean the roof surface, and then there are you have to fix the bamboos, and then there are thatch and all. So, this is something like that, and then I may go to that particular handbook itself, and then we can. So, this is that handbook that you can actually download, or we can provide in our forum. This is National Disaster Management Authority handbook. So, initially these are all the type of the system that have been mentioned. I have just taken from this particular handbook all the references. So, these are the typical the way that we can follow. You can go for the cool roof systems, cool wall systems. So, these are the typologies, and then it is that what we have just now discussed, the bamboo thatch and palm leaf. So, in a page you need I mean visually and graphically they have mentioned everything. Then next one is the green net system. You see, this is also mentioned over here with a figure and the steps of the first, second and third step. This is a medium type of scenario, and it is highly durable, it has noted, and this is going to be have 2 to 3 years of the periodic interval you have to change. Then you can go for the mist kind of a cooling system. You can spray the water in the roof, and then the roof will be cooler, and so this is the way. So, this is roof paint system which has a 3 to 5 years of the age. So, you see there are in this particular thing there are 5 steps. So, it is very informative, this thing very informative handbook, and one must visit this particular handbook and take that one in that application that may reduce down the roof heat gain. It will not only reduce the heat gain, if you have air conditioning in the upper floors, then definitely it will going to give you lot of relief, and if not then definitely it will reduce the temperature, and you can actually go with the ceiling fan or other type of the forced or the natural ventilation. This inverted earthen pot, if you see, it is one of the very old method and very proven method. There are 3 layers. The first layer is this earthen pot, and then you have to put the cement mortar, and then last I go for the IPS kind of a floor finish, the Indian patent stone kind of a cemented floor finish. So, this has given, you see, it is 20 to 30 years is the lifespan. So, this is one of the manual. The other manual is, it is made, it was published by this is also cool roof manual published by the Delhi government way back, maybe 10 years back, because Delhi is in one of the area of the composite climatic zone of our country, and there are a lot of problem regarding this scorching heat summer month. So, they have also pictorial with the pictures and all, they have given the stages of the construction and what to do and how to go with this roof treatment, or this is the ceramic tiles roofing, then this is the some other type of adhesive, and then providing the roof with a light color which is having a high albedo values. So, like that, and if you see, they have done some case studies in page number I think 26 or so. Yeah, this is the page number 26, where they are given the study which is showing, like this is the dotted line which is here. So, this is the pre and this is the post. The pre application time, it was a highly, it is a diurnal variation of the temperature of the roof, and then after the application, you see the amplitude of the variation is quite low, and this is damping actually, this particular the amount of the heat gain is damping. So, this is very interesting. They have also conducted some kind of the study, and the heat flow also, watt per meter square they have studied. This is the first one, is the temperature study. Then the energy wise study also they have calculated, and it shows that there is a enormous amount of the reduction in the temperature, heat gain, also in the energy. So, we understand that the roof is one of the issue, and this can be sorted with this particular type of cool roof treatment. Handbooks are available. Next, we will see the LCS stages. The LCS stages, if you see, it has various stage in some of the literature. It has been used like 7 stage, 5 stage or so, but if you just go with those in detail, and if you just comprehend that one, so we can actually see it is a 4 stage, which we regularly talking since the I think the module number 6 onwards, or maybe 6 onwards. It has one first stage is the product stage, where any material, because you know the rehabilitation or this particular retrofitting is based on the material life, and material has 2 type of life. One is called the technical life, where the technical property will be degraded down to a certain point that you have to remove and you have to put the new material. And there are second way we can perspective, we can see another type of life is the aesthetic life, because of the it discolored sometimes, or it may be fade out. So, we can have to, we may have to change it. So, it is depend upon the material and the material property. So, in terms of the energy retrofit also, we should see those the progress of the material or this equipment or maybe any kind of the object which I going to provide in my the building, which can reduce down my energy bills also from the production stage to end of life stage. So, in the production or the product stage, the raw material supply, transportation to manufacturer and the manufacturing will be done, that we all know. In the construction stage, B1 and B2 are the transport to the construction to the site and the construction installation process. The use stage C2, C1 to C4 are the use, we can do some kind of maintenance, we can repair and replace, and then finally we can retrofit the process or retrofit the material, and at the end we can go for some kind of a demolition, we can give for some dismantling, sometimes we can recover that one and reuse that one or recycle, we can send it to the recycle plant. So, this whole 4 stages of the life cycle analysis we have discussed. So, this same will follow for the any retrofitted material or the retrofitted scenarios. So, this particular side which is the production side is called the upstream the process area. This construction stage is the core the process area, and the use and the end of life stage is called the downstream process area. Now, based on that we understand some of the analysis, the part of the analysis that we have to do for based on this the LCA is 2 more type of analysis we have to actually execute if we have to give some report or any kind of choice basket. If I give, I told you in the last lecture is that we give mostly 2-3 options what type of retrofit a particular client may go for, but just 2-3 options will not going to serve our purpose. We have to give some kind of a thorough analysis of that. So, one of the analysis we did discussed in the last lecture is the economic analysis. We have to find out how much is the payback period. We have seen in the last lecture that the LED lamp gives me a quite handy payback period of almost about 340 days or something like that, if you remember. So, that is less than a year. So, I may go for that, but if suppose the payback period is quite high and quite high is like 5 years or 7 years or something like that, and in between that due to this LCS stage you have to replace the material, right. So, then it will be a difficult, okay, because we I mean the before the payback period I have to replace the material. So, then definitely that particular choice basket I may not prefer. So, that is one of the way to see or analyze a particular the application of the retrofitting the options is the economic payback period, but there are other 2 type of payback period also. One is called the energy payback period, EPBT. So, it is the ratio between the difference of the initial embodied energy and before and the after retrofit and the annual saving of the energy. It is very simple. So, it is giving me a ratio, that means that will also give me how much time I require to get back that one. What get back? Because there is a difference between 2 energies. Of course, those 2 energies are the initial embodied energy of, you see the first one, the initial embodied energy of after retrofit and after retrofit and the before retrofit, there is some delta energy. Okay, so, after retrofit is definitely going to be the high. So, I may say that this E, I stand for embodied, AR stand for the after retrofit is always going to be high with the energy or this embodied energy of the before retrofit. So, before retrofit then only we do something, some material, some more new systems, items or maybe the equipment, and then it is going to be the retrofitted. So, definitely the after retrofit embodied energy is high with respect to the before. So, this delta, this is the delta, the difference is the delta divided by OEAS. OE stands for the operational energy, AS stands for the annual saving. So, how much annual saving I am going to do, how much energy saving, because why I am doing this particular retrofitting, because saving the energy. So, per annum how much operational energy I am going to save, definitely I am going to save it, because suppose I have some kind of graph, I mean this is the time. So, after maybe 5 years I am actually using per year something like this energy. So, then I do some kind of a retrofitting. So, then I will this energy will be decreased, this is the energy axis. So, energy will be definitely decreased, otherwise why should I go for this retrofitting techniques or so after 5 years or after 3 years, whatever. So, this is my saving. So, this particular thing is my operational energy saving or sorry, the annual saving, AS. AS stands for the annual saving of the operational energy. So, then I can, if I see this ratio, then I can say that after some years, after such years, after T years, after EPBT years, I will pay back this energy, whatever extra I am inserting in my building is going to be payback through the energy saving point of view. So, this is one of the analysis we can do, and another one is the CPBT. CPBT is the carbon payback period method. Similar, it is also very similar expression. So, there is also a ratio. This ratio is between the embodied carbon after and before. So, again this is the embodied carbon, this is the embodied carbon I, initial embodied carbon after retrofit must be higher than the embodied carbon the before retrofit. So, this is the delta carbon, is this the difference between them, the delta carbon. So, that much extra amount of carbon is, carbon means it is the GHG gases which equivalent to energies also, because anything we do expenditure is the energy expenditure, and due to the energy expenditure we have to burn coal or we have to burn petrol or so. So, that is why it actually creates some kind of a carbon emission. So, equivalent CO2, equivalent carbon dioxide we have to calculate. It is there in the charts, and everything is there, and because of this particular the renovations or this retrofit, annually I will going to save some carbon. So, it is ACR is the annual carbon reduction. So, definitely why I am going to do it? I am going to do it because this energy will decrease down, annual energy, and is the annual energy is decreased down, definitely the annual carbon which is responsible, my building is responsible for, is going to be decreased. So, again this ratio will give me some tentative timeline or the payback time for the carbon. So, this is the payback carbon time. So, now we will see one small problem and we will end this lecture. This problem stated that a room having 12 meter by 8 meter of the plan dimension and having originally with RCC roof of U value 2. Okay, so, it was initially when it was constructed, this 12 meter by 8 meter of roof is made of by RCC with U value 2. So, now the roof is proposed to be renovated with the EPS which is 75 mm thick, the polystyrene material. To reduce the solar heat gain, the U value of the EPS is 0.3 watt per meter square degree centigrade, which is very low definitely, and that is why it is a very good thermal insulation material. The average solar air temperature of the roof can be taken as 45 degree, and the indoor air temperature can be kept written as set point temperature as 20 degree. So, that 45 and the 20 degree are the two different surface temperature, or maybe one surface temperature, one inside temperature. So, that is the difference in temperature we have to keep. So, there is a heat gain, and that heat has to be removed by some air conditioning also between these two phases of the temperature of 45 and 20. The air conditioning from the room will be used for 10 hours. 10 hours, I must underline that the daily 10 hours I will use that room, and 25 days in a month is and 8 month in a year. So, I will not going to use for all the 12 months, because 4 month maybe a winter month I will not going to use any air conditioner. So, daily 10 hours, 25 days in a month, rest 5 or 6 days are the holidays, and 8 month in a year. So, that this is my strategy, or this is my total gamut of the to calculate the annual energy. estimate the annual savings and all those kind of a thing for due to the renovation. So, first of all I need to see if it is a RCC roof, what was the scenario, and if it is I put the the EPS of U value, low U value, then what is the combined effect of the U value and what is the scenario. So, first of all I found out the combined U value based on the U value of the roof, which is RCC. This is RCC, of course, this is 2 is for the original, this is original RCC, and this will be then renovated or retrofitted. This is RCC plus your EPS. Okay, this gives me 0.26, this gives me 0.26. Now, the surface area of the roof is 96 square meter, 12 by 8, and the temperature difference is 25 degree centigrade. So, we will calculate the roof heat gain, which is the formula which we carry through the very first lecture or very second lecture or so. The heat gain is Q into U into delta T. So, the heat gain through the original RCC roof will be this is my Q 48,000 watt, this is my area, this is my U value, and this is my delta T. Similarly, the no change in the area, no change in the delta T, but there is a change in the U value. You see, this is 0.26 is the U value. So, for that now the heat gain is 626 watt. So, now under these circumstances, that is with the EPS with the RCC roof, I am gaining a heat gain of 626 watt, and definitely it is much less, and I have to responsible to wash out that particular heat only. I do not want to do now 4,800, it is retrofitted. So, my job is less. So, the load on the air conditioning system will be much less with respect to the if it is not retrofitted also. So, the reduction in gain of the heat is this much 4174 watt, and it is going to use for the daily 10 hours. So, this is the hours, this is the days in a month, and this is the number of months. So, almost about 8,348 kilowatt hour. So, this has to be divided by, this has to be actually divided by, this will become in watt, has to be divided by 1000, and then you will get this value. So, 8,348 kilowatt hour will be, now hour is there. So, this much hour. So, kilowatt hour will be the energy requirement for the annual energy requirement, or not annual energy requirement, it is the annual energy saving, you may say, because of the retrofitting. Now, we can go through lot of analysis. First one is again the analysis for the economy point of view. The EPS installation cost is 1200 rupees, sorry, per square meter, and unit cost of electricity 4 rupees. So, I know additional I have to pay 1,15,200 rupees to install that EPS, and yearly saving is 8348 kilowatt hour, that much of unit, and if I multiply with 4, because 4 rupees is the unit of electricity I have taken. So, 33,000 will be my annual saving. I have to put 1,15,200 and annual saving is 33. So, the payback period is almost like 3.45 years. Okay. So, 3.45 years after I will be in gain, I will be in gain, whatever I have invested as a rupees I will get back. So, this is the first type of analysis as the economic analysis. The second economic analysis I am doing it here for the energy payback and the carbon payback. The energy payback, you see, it is given that the density of the EPS is given, the embodied energy of the EPS is given, and also embodied carbon of the EPS is given. So, first I found out how much is the kg of EPS I record, because I know it is 0.75 is the thickness and I know the dimension. So, how much meter cube, and then I multiply with the density, this is the density. So, this much kg, and then this is the embodied carbon embodied energy, this is the EE, I multiplied with the 190, that is kg. So, this much is the embodied amount of the energy that I have actual initial embodied energy have to extra have to provide, that is the first E, the after and before that particular thing. And embedded energy of the EPF installed is I have converted to into the kilowatt hour, same thing I have to convert it to the kilowatt hour. The embodied carbon is now this much, because the 35 is the embodied carbon EC, which is coming here from here, embodied carbon, 35 kg of CO2 equivalent, E stands for equivalent per kg. So, 190 kg embodied carbon, and the annual savings is this much, 8384. So, that I have converted to megajoule, and from the megajoule I have also converted how much is the equivalent carbon. So, now I can easily go through this. I am finding out this is my extra amount of the initial embodied energy required to install the EPS, and this much is my the saving. So, my payback period is almost like 1.26 years, but here please note that everywhere I have written that this is not the exact value, this is I have taken some kind of approximate value and added some kind of a construction materials also with this density, embodied energy and the embodied carbon. So, this one 10526 divided by this 8384 is gives me almost like 1.6 here. And second case what I have to do is embodied carbon case, this is the annual saving, this much carbon, and this is the extra carbon, this is something like 6650, this too has to be ratio down. So, the 6650 is the extra amount of carbon that was imparted in the building because of the retrofit, and 2945 I think let me go back a little bit, yes, 2945 kg of CO2 is the annual carbon reduction. So, that is there. So, it goes almost like the 2.26 years is the payback period from the carbon point of view. So, that ends the module number 7. We will go to the module number 8 next week with the energy generation. Thank you very much.